Hello, students. Okay, so we're going to talk a little bit about parametrics. Okay, so first off, parametrics really describes a particle in motion, and it describes the path that it takes. Okay, and it's given by two functions. It gives the function for the horizontal motion and the function for the vertical motion. So the horizontal motion is x of t, and the vertical motion is y of t. And these two are written in coordinate form. So the coordinate for your x position would be this. The coordinate for your y position is this. And that's described right here. T is called the parameter. And so sometimes it's referred to as time, sometimes it's not, but most often it's referred to as time. The horizontal rate of change being derivative, is the derivative of your x function. The vertical rate of change is the derivative of your y function. Okay? So velocity vector, when you have a vector, it's written not with parentheses, but with these type of parentheses. They're kind of like pointy-like. Okay? And basically it's just taking the derivative of your x function, taking the derivative of your y function, and putting the two together. It can be written in this form. It can be written in this form. And if they ask you for the rate of change of the particle, not specifically the horizontal, not specifically the vertical, but the particle, the whole particle itself, or the slope of the particle, that would be your dy dx, which is what we're used to. And that is also written as dy dt divided by dx dt. So what happens when we do parametrics, we actually write it in this form. And then if you notice, when we do fractions, you multiply by the reciprocals, the dt's cancel out. That is how we end up with dy dx. Okay? So dy dx is equivalent to this, which is also equivalent to this. Okay? The acceleration vector is the second derivative. Just like acceleration is the second derivative, acceleration vector would be the second derivative of each one of these functions. Right? And then particle speed, this is another formula that you need. The particle speed is given by the square root of the first derivative, x prime of t squared, plus y prime of t squared, which can also be written this way. And then you would just evaluate it at whatever t you want. That's the speed formula. And then the distance formula from A to B, t equal to A to B, is written as this. The integral, basically, of the speed. Because distance is equal to rate times time. And so the sum of each one of those little individual points gives us the distance. Okay, so essentially you're taking the speed and timesing it by the time. The integral of that is the distance. So this should be enough information for you to be able to answer some of the questions that they ask. Some other types of questions that they ask is about horizontal tangents and vertical tangents. So we've done a lot of horizontal tangents. When do we have a horizontal tangent? Well, that's when our first derivative is equal to 0. Well, when do we have a derivative equal to 0? That is, if this is equal to dy dt divided by dx dt, it's when our numerator is equal to 0. So dy dt is equal to 0. Find out what function that is, and then solve for t. And that is when we have a horizontal tangent. Vertical tangents. Dy dx does not exist. That's when it's a vertical tangent. So therefore, that means our denominator was 0. So the dx came from dx dt. That was equal to 0. And then you solve for t. Okay, so this should be enough information. You can put these on flashcards so that you can answer some of your parametric questions.